Okay, so for my senior design project, I did a custom course management server and the hardware for the course platform. So, this project was broken down into two pieces, the hardware, which I'm going to discuss first, and the software. I can't spell today. So, in the hardware section, we decided to make a custom server. So, if this little cloud-shaped thing over here is the internet, put a little I in it. We had a server that we designed ourselves, so we'll put a little SER for server, and this server connected to the internet. And basically what this did is all our course platform, courses, software, all our course software, and anything else that relates to the project goes into the server. So how did we do that? Well, to be completely honest, we first set up our server to run Ubuntu. Which is an open source, it's completely free Linux variant. And so what do we put on it? Well, we put on Apache. We put, let's see, MySQL. And we put Postfix. And with Linux, this all is known as the LAMP. So, what does this all do? Well, Apache allows us our database, or actually Apache is the web server. What is it? MySQL or MySQL is our database software, and Postfix is, of course, our email. Now, we actually did not implement email, so we will just cross this one off. So, out of the two, we had to configure both of them. So, for Apache, we had to give it some domain names. So, we chose nsf.engr.csufresno.edu. Now, why do we choose this? Well, this back half, engr.csufresno.edu, was given to us by the university, and so we chose NSF. In addition, we had one other site for our course management software. So NSF is our homepage, and we chose one more called Moodle, double O's. I'm just messing that one all up, so here, let me erase this. Eraser. Ooh, that does not turn out right. No. How do I set this? Here we go. So let's erase all that. Alright. So then let's go right back. Moodle, so W-O-D-D-L-E, I think, or 1D, yeah. So let me cross that out and rewrite it. Moodle, and then all this falls down, dot that. And this is our course management software. Alright. So that's there. Now on the software, well, that was kind of hardware and software. The other part of the project was developing the course platform. So course platform here. Okay. So what we did is we chose a very common processor, the PIC, or processor family, and we chose two. So we chose the 16F series, and we chose the 84A and the 877A. And out of these two, we made a development board. And what this is it allows us to program it, so we can program. And we can, of course, run our programs without having to change any wires, what we're doing, picking it up, putting in different pieces. So that's pretty handy. And that is all the hardware. So now for the software. The software is where things really got interesting, because everything up to this point has pretty much been off the shelf or COTS, commercial off the shelf, except for the development board. So here we have Ubuntu, our LAMP software, Moodle, which is our course management software, and all the code written for the PICs. So how does each of these tie in? Well, let us go down and we will start. So Ubuntu. This is our operating system, or OS. And so what does it allow us to do? It allows us to store data, access the internet, and generally act as a server. And if you have ever used a computer, you always need an OS. Unless you are an expert programmer and like to do stuff the hard way. Every time. Okay, so LAMP. As I explained before, we have our Linux, which was just explained, so I'm not going to explain that again. This is Ubuntu, so go back a few minutes. We have Apache. We have MySQL. And we have Postfix. I'll just abbreviate it like that. And this is not used. So, what is Apache? It is a web server. So what does that give us? Well, actually, on second thought, I do have Postfix installed, but it's not Postfix and LAMP. It's PHP. There's the other one. That's a programming language. So what's it do? What's Apache do? Well, Apache is a web server. So it allows us to dish out HTML files, and it receives requests, and it operates on the network layer. So it's pretty simple. Basically, if we come down just a little bit, we have our little server, we have our little client. The client will send a question, a query, I'll put a Q, and the server will send an answer. Actually, not on the network layer. This is right below the application or the transport. There we go. So what does this not concern itself with? Well, because it's built on top of the transport layer, it doesn't concern itself about if messages get back or not. It always assumes implicitly that they will. So it makes our life easier. It just basically serves as an intermediary between the client and the files that I want served up. MySQL is the database, and this is mainly used for Moodle, and it just stores data. PHP is a web server programming language. So it's a language. It's interpreted. It allows for dynamic web pages. If you've ever seen something that can change a lot, it is probably made with PHP. Alright, now I've mentioned this Moodle a lot, so what is Moodle? Moodle is course management. So, what does that give us? We can create courses, track who's in there, assign grades, post homework, you know, all the standard teaching stuff. And we can duplicate courses for more people. Made easy. And of course it is all on the web. So what does this mean for a student? Well, this is easy. Let me scroll down. For the student, homework is readily available. Always have the due date. And of course, it's pretty much available, and you always know your grade. In real time, you don't have to wait for a professor to tell you. For the instructors, biggest thing, no losing papers. Man, I cannot spell that. O should not be there. Losing assignments. You can notify the entire class simultaneously. And you don't have to print out as much. Okay. So that is that for the software. Now there is a couple more things. The software for the PIC. So PIC software. Up to now, this has all been pretty much off the commercial off the shelf. It's not really paying for it, but it's still called commercial. PIC software. So we program in MPLAB in either C or assembly, and we push the code, push binaries to PIC, through PICkit2. PICkit2. Okay. So now in this PIC, oh boy, I am running out of room fast. So there is 13 modules. LES. So module 1 shows how to use PIC. Labs 2, 3, and 4 get more familiar. Labs 5, let's see, what was Lab 5? I think Lab 5 was just inputs. Store I/O, 6, interrupts, 7, oh, okay. So my memory is kind of shy on these, but it's probably the LCD screen, putting stuff on it, writing to an LCD screen. Lab 8 was a, let's see, how many, 12 key keypad, 12 key keypad. Lab 9, stepper motors. Lab 10, DC motors. 11, DC motors again. But with real PWM, not pseudo PWM. P, not B. PWM. 12 was ADD conversions using the rangefinder, and DC motors from Lab 11, and Lab 13 was multiprocessor communication. Or as most people like to call it nowadays, multi-core and networking are the two types. Okay, so if we come back up a little bit, so then what is the overall goal of the labs? 1, 2, 3, and 4, nothing much, just get familiar with the language. Okay, 5 is general I/O, so still getting familiar, but a little bit less. 6, interrupts. Why do we want to interrupt? Well, we want something to resemble parallelism. If I could spell, this would be right, but it's not, so this is wrong spelling. Lab 7, oh boy. LCD, we want to show some real meaningful I/O. So, readable I/O. You don't have to be a genius that knows binary like the back of your hand to read it. You can read it in human words. Keypads. Readable inputs. I don't want to be switching switches. I don't want to be pressing buttons that tell me what exactly the number is. So instead of switching up A101 and switches, I want to press the button 5. So readable outputs is 7, and readable inputs is 8. So these all have videos, by the way, you can watch them. It'll explain more in depth what each one is going over. Lab 9, which is stepper. We want to know how far motors turn. So in a DC, it'll spin as long as it has power. In a stepper, you have to control the timing of it. So for number 9 and the stepper, we just wanted to turn a motor simply. 10, control the speed of the motor. 11, do it more accurately. 12, we want a feedback loop, so feedback control. And 13, we wanted the ability to process more data faster, and we didn't want to run out of memory, so we wanted to double our processing power. Also, as a hidden benefit, we wanted to show off that we can communicate across long distances. So we'll put that in. And that is the entire lab, or the entire senior design class.